Yeah, good morning everyone. So in the previous session, I covered what are the different types of performance testing, and we had one quick assessment, right? I have shown you some graphs, and if you remember, I asked you to identify each of those graphs, right?
Yes, sir.
We'll have some quick assessment before starting the session. Okay, not that graphs, but I want to have some, I want to take some quick assessment, okay? So I explained what are the different types of testing, and I explained all those types of testing in detail, and we had some quick assessment on the previous day concepts. So I have shown you some graphs, and I asked to identify what type of test is this, right? So now So the reason is behind this exercise is in some interviewers will ask you to draw the graph. They will not show you the graph. Please remember that. They will ask you to draw the graph for a load test or for a spike test or a stress test. So that's the reason for this exercise. Clear, guys? Now coming back to this, so let's have some quick assessment before moving on to the next session. All right. Before moving to the next concept, let's have some quick assessment. So Chaitanya. So Chaitanya, what is a load test?
Hello?
Yes. What is a load test? Or else, what are the different types of testing in performance testing? What are the different types of performance testing?
There is two types, sir. Functional testing and non-functional testing, sir.
No, I asked what are the different types of performance testing. I didn't ask what are the types of testing. My question was, what are the different types of performance testing?
Different types of performance testing. Sir, spike test, load test, like
yeah,
sir,
load test, spike test.
soak test, sir.
Okay. Indraja, what are the other test types? Chaitanya told about load test, mentioned load test, spike test, and soak test, right? What are the other performance test types, Indraja? Supriya?
Scalability test.
Sir, stress test. We have a stress test, spike test, volume test, stability test, and failover test.
Right, perfect. Right. What is stability test? I told I did not explain that, right? Scalability testing.
Yes.
Scalability testing. I covered scalability testing.
Yes,
isn't
sir.
it? Yeah,
yes, sir.
Good. So what is load testing?
So load testing, where we gradually give an expected load on the application like 1 to 2 hours and see how the application is learning. It's only for the short period of duration, that is 1 to 2 hours.
Yeah, how the application behaves, or how is the application behavior, or how the application is responding.
Yes, sir.
Right? So load test is something which we do with normal user load on the application for 1 to 2 hours.
Yes, sir.
Right? Akila, what is soak test?
It is a test done for long duration test based on business hours to identify memory leaks and connection leaks. It
Excellent.
Can be 4 hours or 8 hours or 1 day, 3 days, in that way.
Perfect. Yes, thank you. Ganesh, what is stress test? Okay, Ganesh is in traveling during this time. Yeah. Next, Karishma, what is stress test? Karishma?
Yes, sir, I'm here. What did you say?
Yeah, what is stress test?
Stress testing, right? Testing stability and response time by applying the load, which is more than the design number of users, sir. Which is more than, am I correct?
More than the expected user load.
Yeah.
And what is spike test?
Spike test is nothing but it basically involves the application which have a feature of sudden increment in number of users, and also the quick drop as well.
Okay. Siri, what is volume testing, Siri?
Yes, sir.
What is volume testing?
Class 6, sir.
Sorry? Subhadatta?
Yes, sir. Volume testing is normally when we test the application with a large load of data to check the behavior of the system. That is known as volume testing.
Right. When there is certain volume, certain large volume of data in the database, right? So in volume testing, we test the application behavior when there is certain large volume of data in the database, isn't it? And which one represents this volume testing? Out of these graphs, you are seeing graph number from 22 to 26, right? Which graph represents volume testing?
26.
Right. And which one represents stress testing?
24.
Right. So this represents a stress test, right? So here we are gradually increasing the user load. And what is the objective of doing this stress test?
To identify if our application is sustaining with increase in load and it is running for a higher period of time, longer period of time. And
Wait, did I mention about duration in the stress test? No, right?
No, sir.
Just to identify, how far this application works and to identify the breakpoints.
Right. Application breaking point, to identify the application breaking point. What is this one? What type of test is this?
This is spike.
Right. And what is the normal user load here? And what is the spike? Can you identify like what is the normal user load and what are, can you
Yes.
can you mark those? I'll give you control.
Okay.
I'm giving you remote control.
Normal.
Yeah. You got a control now. Yes. Can you mark like what is the normal user load and what is the spike here in this graph?
Yes, sir.
Which part?
Sir, can you please help me to open that
Okay.
marker?
Yeah, sure. Annotation. Let me open annotation. Yes.
Yes, sir. This is the normal load.
Yeah, try it at the bottom. Okay, let me clear it. Hold on. Please wait. Yeah. Mark the normal user load at the bottom and show the spikes on the top.
Okay. This is the normal user load and sorry, sir.
No, that's
This is the spike.
Right. Right. And what is x-axis and what is y-axis? What do we see on x-axis and y-axis?
X-axis is the test time.
Right.
And the y-axis is the load. I mean, that is the users joining, logging into the application at the for that period of time.
Perfect. Right. Okay. Thank you, guys. So, shall we move to the next concept, or if you have any queries, we'll discuss. Shall we move on to the next concept, which is I want to discuss like types of performance testing in detail. Yes, every day we'll have one quick assessment on the previous day concepts for the first 5 to 10 minutes. Okay. So I'm taking control so that okay from you. And also, after 1 month into the training, I'll share you an online assessment where you will be having 30 questions, 30 multiple choice questions, which you should answer in 30 minutes. Okay. So after 1 month into the training, I'll share that online assessment. So once you attempt the test, I will get a mail like this. So I will get a mail like this, and also you will also see your score like this. Right? If you click on detailed score, okay, and all these will be multiple choice questions. So you have to answer 30 questions in 30 minutes. All right then, so let's move on to the next concept, or the next topic is what is application architecture, what is 2-tier versus what is 3-tier, and what is a typical 3-tier architecture application. So first let's understand what is meant by an application architecture, right? So application architecture means pictorial, suppose any web application, it can be any, it can be either a web application or a mobile application, right? Or a desktop application. So what is meant by architecture means architecture is nothing but, application architecture is nothing but pictorial representation of an application's components. Components means parts, right? That is the general meaning of component, right? So in the application architecture diagram, all the servers of that application will be represented in a diagram in the form of a picture, right? So it is a pictorial representation of an application's components, software, and connections. Application architecture diagram helps us to understand how these applications interact with each other to meet the business or user requirements, right? I'll show you some architecture diagrams in the next session. So first let's understand what is meant by application architecture and what is meant by a server. So here we came across some new term called server, right? So let's understand what is a server. Is this definition clear, guys? What is meant by application architecture? Is that clear?
Yes, sir.
Please. No? Okay. So let me explain in detail with the help of a diagram. Okay. Suppose this is a typical 3-tier architecture, application architecture. This is the diagram of a typical or a traditional 3-tier application architecture. So if you observe here, I'll explain this diagram. So I'll explain this. Any application will have, okay, so when thousands of users are, any user is accessing the application using the browser, right? Suppose you type gmail.com or you type amazon.in or flipkart.com, right? Or bigbasket.com, right? So whenever you access any application from any browser like this, see, this is a typical web application architecture. Your request will first go to something called web server, and then application server, and then database server. So architecture diagram is nothing but the pictorial representation of the server or the components of that application. Okay, so that's what I mentioned here. It is a pictorial representation of an application component, software, and connections, and how these applications interact with each other to meet the business or user requirements. Say for example, you type gmail.com or flipkart.com or bigbasket.com, right? You are accessing any application like this. Okay, so let's say amazon.in, right? So you are sending a request to the server and you got response from the server, isn't it?
Yes.
So from a browser, we used a browser and we accessed the application, right? So what happens is in the behind the scenes, what happens is whenever you are using any browser and accessing the application, your request will go to the Amazon servers, right? It will go to the Amazon servers and you will get the response. You are getting the response. Yeah.
Yes.
1%. Okay. Now this architecture diagram, what does the architecture diagram help you understand is how these servers interact with each other to meet your business or user requirements, right? Suppose you search for some product here. Let's say, for example, you search for some product. Right? So all these details will be, see, for example, all the products available which are matching with this search item, with the search item. All these products will be available in all these details will be available in the Amazon applications database server, right? All these details will be there in the database server. So when you send a request to that, right, first your request will go to the web server, and then it will go to application server, and then database server. And application server will get those details from the database server, and it will send to web server, and web server will send it to the browser. That is what happens in the background. Like when you search for some product, or let's say, for example, you search the ticket availability on Redbus, right? Okay, Redbus is not a right example here, so I'll explain why later on. Suppose you search for like train availability from one station to another station, right? When you click on search, right? So you are getting all these details, right? So what are the trains available between these two stations, and what is the time of that, what is the departure time, and what is the availability on each class, right? All these details will be stored in the database server, and your application server will get those details from the database server, and it will send to web server, and then web server will send the response to the browser. So this is how a typical 3-tier architecture or a typical web application works. Let's limit this to web application. We'll discuss about other types of applications later on. Is it clear so far? Did you understand this statement?
Yes.
Yes, sir.
How these servers interact with each other to meet the business or user requirements. Is this statement understood now? Okay. And also architecture diagram shows you what are the servers in that application, what all software are there, and what are the connections, how are the connections going from
Server to
yeah. So it will show what are the connections available, means how these components are connected with each other. How these components are connected with each other. You see some connections here, right? Observe here, you are sending a request, and you see a two-side arrow mark because you send the request and receive the response. Again, you see a lot of connections in between, right? Isn't it? So your architecture diagram shows like what are the application components, or what are the servers involved, and what are the software. I'll come to this. What is this software and all, and what are the connections involved in that application, right? And what is meant by a server here? So server means it is a software or computer program or hardware, right? I heard that there was an interview question like when someone was attending an interview with some 3 years experience, right? So once, not my students by the way, okay. So one of the interviewer asked this question: what is meant by a server? Right? She wouldn't answer that question. He or she could not answer that question. It seems. What is meant by a server? Right? So basically, server is a software or a computer program or hardware which understands your request, processes your request, and sends back the response. Which understands your request. Let's say, for example, you sent a request to Amazon. You have sent a HTTP request to Amazon, right? You just typed amazon.in or flipkart.com, right? You are sending a request to the server, right? What request? You are requesting this amazon.in homepage. That is a request, and this is the response you got from the server, right? And in case of Flipkart, this is the response you got from the server. Are we clear on request and response first of all?
Yes, sir.
Right. So a server is a software or a computer program or hardware which understands your request, processes your request, and sends back the response. Are these 3 statements, are these 3 lines understood now? It can be a software or a computer program or hardware. Is it clear? See, suppose there is a computer which you are using for, on which this application is running. So you can call that also as a server, that hardware, right? Or that box on which that application is running, right? That is also, we can call that as a server. Or else, here also we have some web server, application server, database server. These are not, when you say web server, when you say web server, it is not a hardware component. All these 3 web servers may be running on a single computer. Okay, I'll explain that in detail. First, is this statement understood? What is meant by understanding the request, processing the request, and sends back the response? Is this understood?
Yes, sir.
And now, so whenever you join a project, I'll come to the questions. Okay, so whenever you join a project, right, first thing you have to ask is a performance testing project, right? Or whenever if you join as a functional testing, so you should know what is the application architecture of that project, of that application. Okay, so and that helps you to understand what are the softwares, what are the different servers of in that application, and how the connections are established between each server, and all these details, how your request will be processed, right? You'll get all those details from the architecture diagram. there are few people from civil background, right?
Yes, sir.
Can you relate this to your civil background? What is what is the equivalent one in your in your civil background? I think you have something called blueprint or something, right?
Yes, yes.
Yeah. Any questions here? Someone is asking something.
Yes, sir. Hari here, sir. So, like, what does it mean, like web server?
I'll come to that. I'll explain that when I am, when I come to this slide deck, I'll explain what is web server, what is application server, and what is database server, and sorry, what is the difference between web server and app server. I'll explain that soon. All right. So
Okay.
let's move on to the next one. So 2-tier versus 3-tier architecture. If you remember, I gave some examples already to this concept. Okay. Suppose your work. So let's take a bank example. Right. As an end user, most of us, all of us are having a net banking account, isn't it? Sorry, net banking. You have net banking. Yes, you have a net banking account. Or else, whenever you have a bank account, you will be using through net banking, isn't it? Yes. If you want to do some fund transfer or if you want to make some payment, you can do that through net banking, right?
Yes, sir.
Yes, sir.
Yes, sir. Yes.
So basically that is a web interface, right? So let's say, for example, if you are using ICICIbank.com, right? You are using ICICI Bank's net banking application, wherein you are using a browser to access the application, and you are carrying out your transactions, whatever transactions, fund transfer or bill payment or whatever it is, right? But if you go to a bank, suppose you want to deposit some cash or you want to withdraw some cash, right? And you go to a bank, will the bank employee use the same net banking application like us? Will they use this ICICIbank.com
No, sir.
or if they,
No,
do
sir.
they use HDFCbank.com?
No.
No. Right? They will be using some core banking application like Finacle. In India, most of the banks use this software called Finacle. And remember, this is a product of Infosys. This Finacle application is developed by our Infosys company, right? Most of the banks are using this in India at least, right? So they will be using this Finacle application on their machine, on their desktop or laptop, right? So they will not use a browser like us, and they will not use the browser based application, but they will be using the application installed on their machine, right? That is the best example for this 2-tier architecture. So they will have some client installed on the machine. Finacle software client will be installed on their machine, which may be developed in C++ or .NET or Java, and that will be communicating directly with the database. Or of course, there will be some application server as well here, right? There will be some application server here as well. So, but they will not be using a browser basically. That's what I want to say. But whenever you are using a browser, right? So, but as an end user, we will be using some browser, right? Because installing the application is not required for us, isn't it? We can use any browser and access the URL and use the application, right? So all browser-based applications falls under this 3-tier architecture. As an end user, we will be using any browser like Internet Explorer. IE stands for Internet Explorer, or we have Edge now, right? IE was replaced by Edge browser, right? Or Chrome or Firefox, and we'll be accessing the application like this from a browser. So all these browser-based applications falls under this 3-tier architecture, whereas these are called as desktop applications or thick client applications. So thick client versus thin client. So These are also called as thick client application is also called as a desktop application. So, and these thin client, what we call thin client application is all browser based applications, web applications, right? Or let me put it in this way, browser based applications. Browser based applications are called as thin client applications. So let me explain why they are called like that, right? Suppose if you are using a desktop application, for example, right? See, and let me give one more example for this. Every one of you joined this meeting through Zoom client, right? Did you install the Zoom application on your machine or you joined from a browser?
Zoom application.
Right. So install some Zoom client on your machine, right? And we can also attend this meeting, Zoom meeting from a browser by going to zoom.us, right? By going to this URL zoom.us, let me show you quickly that one. You can join this meeting, or you can also join this meeting by going to opening a browser and go to zoom.us and click on this join a meeting. Right? You can use this feature also to join the meeting. There is some issue with Chrome browser with Zoom meeting. Somehow it's not working, right? So you can join the Zoom meeting by clicking on join a meeting, isn't it? And if you enter the meeting ID here and click join, you can join from a browser also, isn't it? So then you are using a browser based application, isn't it? You are accessing the application, you are accessing.
Then my voice in butler, sir.
Is my voice not audible for everyone? That should be issue on your side, Chaitanya. I don't think so.
Now you can audible.
Oh, okay. Right? So you can use Zoom meeting in two ways. One way is you can install the Zoom client on your machine, Zoom software on your machine, and you can join Zoom meeting. That's how you join now. The other option is like you can join the Zoom meeting from a browser by going to this URL. Right? So then you are using a thin client, means you need not install anything on your machine. So that's why this is called as thin client. Already you have some browsers installed for accessing any application. You need not install anything on your machine. So if you are using a application through a browser, right, that becomes a thin client application. We call that as a thin client application. But if you need to install some application on your machine, we call that as a thick client, because here it will take more CPU and more memory and some disk space also, right? And that's why that is called a desktop application. If you are using from the desktop, that is called a desktop application, and if you are using from a browser, that becomes a web-based application, web application. Is it clear what is the difference between a thick client and thin client?
Yes, sir.
Yes, sir.
And we call this as two-tier. Right? These thick client applications or desktop applications are called two-tier applications, and this is called as three-tier application. It should be pronounced as tier. Okay. Are we clear so far? What is the difference between a thick client and thin client application?
Yes, sir.
Or
Yes,
what is
sir.
the difference between a two-tier and three-tier application?
Yes, sir.
Right? Shall we move to the next one?
Yes, sir.
Right. Now let's understand what is the architecture of a three-tier application, right? So as an end user, different users will be using different browsers. That's why we have Internet Explorer, Chrome, and Firefox, and so some users may be using Edge browser, some users may be using Safari browser. There are a lot of browsers, different types of browsers in the market, right? We have Edge browser, we have Brave browser. There is a new browser called Brave, right? Have you ever used that, or do you know that?
No,
There is
sir.
one new browser,
sir.
like I think which I came to know that last year. So this is Brave browser. So good thing with this browser is like it will block all the ads. It will not display any ads. Understood?
Okay.
That is one good feature of this Brave browser. So in this also we have Netscape and Safari, a lot of other browsers, right? So, and whenever you access any application from any of these browsers, your request will first go to the web server, something called web server. Okay, I'll explain this load balancer later on. I'll explain this, what is this load balancer later on. Okay, first let's understand what is this web server and why it is called as presentation tier. It's called as presentation tier. Let's understand why it is called as presentation tier and what is application server and why is it called as logic tier and what is database server, right? First let's understand your request will first go to the web server. Let's say for example I open a new browser and type let me close this and come. Let me open a new browser and let's say I type gmail.com, right? The first time you access Gmail, every user will see the same page. Yes or no?
Yes, sir.
Or else if you take IRCTC example, right? You type irctc.co.in. Every user will see the same page. Yes or no?
Yes, sir.
And this
Yes.
page doesn't change frequently. This is a static page. This is a static page. Of course, the date will change, except that the page, the images, and all this doesn't change. Yes or no? Right? So whether you type gmail.com or IRCTC homepage or ICSbank.com, right? These pages doesn't change frequently. Yes or no? And everyone see this page only, the same page. Yes or no? Agree with me?
Yes, sir.
So this is a static page. When I say static, what is the meaning of static page?
Stable.
That doesn't change.
Static is
Stable.
Right. Static means that does not change frequently, right? That doesn't change, right? And two terms here. One more term you have to understand is dynamic. What is dynamic?
Changing.
Right? Let me use this one. Dynamic and static meaning, right? So dynamic means it is capable of change, which changes, right? Static means stationary or fixed, isn't it? Understood, guys? Static means stationary or fixed, isn't it? Dynamic means which changes, capable of action or change, right? So why are we discussing this is all the static content. If you are sending a request for static page, all that static content will be served by this web server. Means when you access the home page of Gmail or ICSbank.com or IRCTC, your request will go to web server and then web server will send the response to you. It will not go to, there is no need of that request going to application server or database server, right? So your web server will serve that purpose. It will serve that static pages. Is it clear, guys? Now, when does this application server come into picture? Let's understand that. I'll take the same example and suppose you search for trains from one station to another station. And if you click on search, right? So I told you just before, right? All these details will be stored in the database server, isn't it? All these details will be stored in the database server.
Yes,
Now, your request will go to the web server, and whenever there is some, and also one more thing, observe here, this data changes frequently, right? This, at least the availability details and all changes, yes or no?
Yes, sir.
So can we call this as dynamic content?
Yes.
yes.
Right? This numbers changes, right? Availability and all changes. Wait list number, availability
Waiting
number,
list
all
and
these numbers
availability.
changes. Right. So web server will not have these details. In such cases, whenever you search for trains between two stations, or whenever you log into Gmail, right? Say for example, I log into my Gmail. Okay, so I enter my email address here and click on next, right? Right? Now it should show my inbox. Once I log in and once I enter my credentials and log in, it will show my inbox. If you log in, it will show your inbox. Right? Again, this is dynamic content, right?
Yes, sir.
Yes,
Which has to be changed.
Right.
And we
So-
always we need to get the new updates also.
Right. So whenever you are sending a request for dynamic content, right, then application server comes into picture. And this is called as logic tier. Why this is called as application tier or logic tier is, suppose you search for trains between two stations, right? So it should process some logic. Means it will run a query in the background, something like this. It should run a query like this. Once it should run a query like this. Select all star means all trains. Select star from trains table where departure city is equal to let's say Hyderabad. You search from Hyderabad to Bangalore, right? And destination city or arrival city, right? Destination city is equal to from Bangalore. Okay, so it should, application server will run this query, right? It does this processing. It processes this query, right? It will run that. It will have, application server will have that code or logic for getting all the trains from Hyderabad to Bangalore or whatever cities you select, and that details that all the trains details will be stored in the trains table on the database server. So it will process some logic and it will send you the response, right? So that is where your application server comes into picture. That's why this is called as logic tier or application tier. Clear, guys? So any dynamic content, any request for the dynamic content will be handled by application server and database server. Any request for static content will be served by the web server itself. If you are sending a request for a static page, that will be handled by web server itself, right? And now if you are searching for trains, or if you log into the application and it should show you the inbox, the Gmail application or whatever it is, it should show you your inbox, right? Then what does it do? This application server will process that logic, verify your credentials. Again, credentials will be stored in the database, right? It will verify whether you entered a correct password or not. And then it will get your mailbox from the database, and application server will send the response to web server, and web server will send the response to the browser. So that is how your request will be fulfilled, or your request will be processed, right? Now you understood what is this web server, application server, and database server?
Yes, sir.
Yes, sir.
All right. So now so I'll explain this load balancer. What is this load balancer and all later on. Okay. For now, understand, when you say a 3-tier architecture application, what are the different components, or what are the different servers, and what is meant by a server, and what is meant by web server, application server, and database server. So all the static content will be served by the web server, and all the dynamic content will be served by application server, right? And if required, this application server will connect to the database and get the details from the database, and it will process your request and send to web server. Web server will send that response to the browser. Finally, web server will send the response to the browser. Clear, guys?
Yes, sir.
Now let's understand now what does this presentation layer, logic layer, and database layer consists of, right? So in this diagram, I'll try to help you understand what does this presentation tier. So you see here, right? Presentation tier, logic tier, and persistence tier. So presentation tier will be made up of HTML, CSS, and JavaScript, right? See, whatever presentation layer means, this is nothing but this one, the page that you are seeing, right? The page that you are seeing will be typically made up of HTML, CSS, and JavaScript. Shall we see that? Let me try to show that. Right click anywhere on the browser, on the page. Okay, hold on. And click this view page source. Everyone, please do this. Open any website and use this option, view page source. Can you please do that, everyone? You see something here, doc type HTML. Guys, are you with me?
Yes, sir.
You see some at the top, you see some doc type as HTML. Means doc type means document type. So this is a HTML document. Means what is this HTML stands for? Hypertext. You know that, right? I hope everyone knows. Right. HTML stands for Hypertext Markup Language. So that is the language in which your HTML pages are designed, right? All these websites are designed. That is the language in which this is designed, right? So apart from HTML, you have something called CSS. Let me show you that. I'm searching for CSS. Control F. You can do Control F to get this window, this one, right? Search for CSS. You see here, there are some CSS files. Observe here. You see some folder. Let me show you the CSS file name. Yeah, see here. NLI revamp library min.js and something called custom min.js, right? Oh, sorry, .css. You see some CSS files, right? jQuery.multiselect.css, right? So this is the CSS that is mentioned here. I'll explain what is the purpose of that CSS soon, right? So any web page is made up of HTML, CSS, and JavaScript. Let me show you the JavaScript also. Typically, most of the websites are made up of these three components. .js. Search for .js. You see here, there is something called Google Analytics.js, GTM.js, isn't it? There is something called tab 126657.js. So any web page that you see will be typically made up of HTML, CSS, and JavaScript. Okay. So your presentation layer means whatever you see in the browser. That is typically made up of HTML, CSS, and JavaScript. Now let's understand what is the purpose. We know HTML. So suppose you know what is the HTML used for. That is the language in which your web pages are designed. Okay. You can see what is HTML. So hypertext markup language, it is the standard language for creating web pages. It is a standard markup language for creating web pages. Are we good here? Yes, are you with me?
Yes, sir. Yes, sir.
Yes, sir.
So
Yes, sir.
this HTML language will be used for creating web pages, right? Now, let's understand what is the CSS and JavaScript. Okay. So any web page consists of, let's take this example. Any web page consists of some buttons, some images, right? And some drop down. Here is a drop down, right? And if you click on login, right? So it will show you some text box. These are called as text boxes, isn't it? This is a text box and this is a drop down.
Drop list. Pick
Right?
list format.
Right. So these are text boxes and you have a button here, right? So, right, all these text boxes and buttons will be developed using HTML language. Okay, these drop downs are a checkbox. This is called as a checkbox. All these checkboxes, right, are these text boxes, these buttons, all these will be developed using HTML language. Now,
CSS.
apart from this different components, web page components, you have something else like this. ICSA bank image, right? It should be displayed over here, right? And you see a button in orange color, right? And of course, this will be written in HTML only, or the color will be defined in HTML language only, but it should be displayed at here, at this position, right? All this layout will be defined using CSS. Means, this logo ikkada undali, this button ikkada undali, or a text box should be displayed here. Next to the text box, there should be a that keyboard icon, right? All this layout will be defined in CSS file. So that is the purpose of this CSS. This one. CSS stands for cascading style sheets. Let me show you that. What is CSS? Let's Google for what is CSS. What is CSS? CSS stands for cascading style sheets. CSS describes how HTML elements are to be displayed on the screen, paper, or in other media. What does CSS does? It describes how HTML elements are to be displayed on the screen. When I say HTML elements, what are the different HTML elements?
Text box, drop down buttons.
Perfect. Right. Those are the different HTML elements: text box, drop down, or check box, radio buttons. All these are called HTML elements. Now CSS describes how these elements should be displayed on the screen. Right? And CSS stands for cascading style sheets. Is it clear, guys?
Yes, sir.
Right? So that is the purpose of CSS. Now, how about this JavaScript? What is the purpose of this JavaScript? Let's understand that. Right? So JavaScript is used for, first let me explain, let me search what is JavaScript. Guys, why I am showing like this is you can do this after the session. Right? After the session, you can go through this, right? You should explore in that way. And let me show you one more thing. So instead of typing here, right? So let me go to CSS or JavaScript. I have one separate slide on this. Let me show you that. Here it is. So you see here, CSS stands for cascading style sheets. CSS describes how HTML elements are to be displayed, right? So what you can do is, when you are going through this material, I shared this material to those who confirmed your joining, right? So you can right click and use this option, explore JavaScript, right, on the slide deck. Then it will show you the Google search results. You need not open a browser and you need not type it again, the whole thing, right? And if you want to understand what is XML, just right click and explore XML, right? Explore XML. It will show the Google search results here itself. You like this? Like this tip?
Yes, sir.
Yes, sir, I like.
Right? So you can use this feature, guys, right? You just right click over here and use this option, or remember this shortcut, Ctrl-Alt-Shift-I. All right? Yeah. So coming back to this. So what is JavaScript? So JavaScript is a programming language for the web. It can update and change both HTML and CSS. It can update and change both HTML and CSS, right? So basically JavaScript can calculate, manipulate and validate data. And in the bracket I mentioned as client-side validations. Let me explain what is this client-side validation. Okay. What is meant by client here, by the way? When I say client-side validation, any guess what is meant by client here? Client is nothing but browser.
Browser.
Right? Okay. Now what is meant by client-side validation? Let me explain that. So you type gmail.com, right? I'll take the same gmail.com example, right? Suppose you are on this page, you are supposed to enter either your email address or phone. Yes or no? Yes. Are you with me?
Yes, sir. Yes.
Right? Suppose you need to enter either your email or phone number. So this is a valid email address, right? This is a valid email address. And if I click on next, it should ask me the password. The application should prompt me the password, right? But suppose if you enter some junk characters like this, is this a valid email address? It should give you an error.
It should give you an error.
Right. So if I enter some special characters, okay, let me do one. So if I enter some special characters like this, right? If I click on next, what should happen? It should display some error message like this, isn't it? So this is called as client-side validation. Means this validation, whether it is a valid email address or not, right? So whether it is the format is valid or not, right? So no email address can exist in this format, right? Right. So this validation will happen on the browser itself, right? Then that is called as client-side validation. This particular thing will not go to the Gmail server, right? Whatever characters you entered, right, need not go to the Gmail server, right? And this validation can be happened in the browser itself. If the validation happens in the browser, then this is called as client-side validation, and that code will be written in a JavaScript file. whatever code is required to validate this, right? That code will be written in the JavaScript file. So that's why here you can see JavaScript can be used to calculate, manipulate, and validate data, right? And client-side validation. So mostly JavaScript is used for client-side validations. Now, is it clear what is the purpose of why do we have three components in the presentation layer, and what is the purpose of each?
Yes, sir.
Tomorrow we'll have an assessment, guys. All right.
Yes, sir.
Yes.
Right? Next comes logic tier. So in this diagram we have logic tier. Right? So this logic tier or presentation, the application tier will be developed in some programming language like Java or .NET or PHP or Python. That's what this diagram tells you. Right? This application tier will be developed using some programming language, any of these programming languages like Java or .NET or PHP or Python. And this database layer, we have one more tier called database, right? So there are different types of databases like MySQL, SQL Server, Oracle, PostgreSQL, you have MongoDB, you have SAP HANA. So your database layer can contain any of these database servers, right? And nowadays, so this is all about presentation layer, logic tier, and database tier. Is this clear or any queries here?
Clear, sir.
And this is the web layout, means when you are accessing any application from the browser, this is how the layout will be, isn't it? But if you are accessing any application from the mobile browser, this is how the layout will be, right?
Yes, sir.
Right? So one more layer got added here. We have web layout and mobile web browser layout. This is the new one that is added, right? So that's why that is called as N-tier architecture. So anything, see, 3-tier, 4-tier like that. So anything above 3-tier, that it can be called as a N-tier architecture, where N can be any number. When you say N-tier architecture, N can be any number. Is this clear for everyone? What is N-tier architecture, and what is what are the different components, or what are the different components of a presentation tier and logic tier and database tier?
Yes, sir.
Okay. So shall we move to the next one? Oh, it's already 9:40. I'll stop it here, guys, for today. Right? So we will continue with performance. Tomorrow I'm going to explain. Before starting performance testing life cycle, I want to explain you what is some HTTP basics. I will take this later. Tomorrow I want to explain HTTP basics, HTTP request and response. Right, and then I will explain the performance testing life cycle. Right, see you same time tomorrow. Let me pause recording. And for recording purpose, thanks for watching and have a nice day. Like, share, subscribe to me.